So the project I would like to share from the Centre for Circular Design is Fast Forward Fashion. It spanned 6 years and was funded by the Mistra Foundation in Sweden as part of the Future Fashion programme. The Fast Forward research was built out from 3 proposals relating to different short life product lifetimes and recovery routes. So paper leather was designed for paper recycling, Pulp-It designed for industrial composting, and Laserline designed for chemical fibre recycling. Recognising that disposable fashion forms part of most wardrobes, the Pulp-It compostable concept was to develop a sustainable and inexpensive fabric with an intentionally short lifespan. Ideally, it could be recycled or industrially composted at the end of its life. It was made from a novel blend of unbleached wood pulp and complementary bio-based materials, and a non-woven fabric that was designed from the fibre up in collaboration with material and environmental scientists, combining old and new techniques and adapting finishing processes to change the material properties. This focus on practice really pushed the research forward, I think, in some key areas. So firstly, in the process of collaboration itself, we used the material samples and prototypes as translators. Initially, there were problems of communicating amongst the diverse team on how best to describe the qualities we needed. Some researchers would talk in terms of softness, warmth, aesthetic, and others in a language more akin to measurement, breaking points, light refraction, sound. To create a common understanding, we provided a sample of cashmere as reference, and at the end of the project, when tested in a set of perception studies, users marked out our sample as desirable compared to a whole set of other fabrics and second only to the cashmere. Secondly, at the start, the goal was to identify a perfect blend of fibres through testing different combinations. However, the bio-based textile fibres we were using made the materials soft but weak, and the cellulose-based paper fibres made them durable but stiff. So finding this perfect blend where the material could be both soft and strong in equal measures seemed impossible. The material science got us close, but it was through application, trial and error with various textile finishing processes that we could really achieve and control performance qualities as we needed them. And finally, I think building recyclability into the brief from the start was a large part of the project, and any of the finishes we used to improve the quality of the material had to fit in within this strict set of boundaries. By engaging with the material scientists at the early stage, we tailored processes to ensure recoverability. In one instance, we discovered that a method we'd used to improve the strength of the material also resulted in improved softness and added a degree of water repellence. And not only that, it also increased the rate at which it composted by wicking water directly into the fibres. It really was a win-win. I think the really vital part of this project was in the bringing together of design practice alongside the scientific experiments. Each discipline could respond to the other in real time, and through iterations of collaborative development, accelerate the innovation process. I think there's so much potential for research that works in this way in the future, and it's something we definitely want to do more of through our research at the Centre for Circular Design.